Hello everyone, thank you for joining. Let's give it maybe one more minute and then we will start with the webinar. All right, then thank you very much for joining and welcome to the webinar about GraphQL. So this is what we're going to do today. We will be looking at how you can use GraphQL and what it actually is. We will discuss some common API vulnerabilities that arise when you're using GraphQL. We will also talk about some general security challenges that you will face when you're using this kind of API. And of course, we're also talking about how to use DAST to scan a GraphQL-based application. But before we start with the webinar, I want to give you a quick introduction on who we are. So we are Invicti. We have been a global leader in web application security since 2005, with our headquarters based in Austin, Texas, and branches located in Malta, Turkey, and the Czech Republic. We were established as a result of the merger of two prominent cybersecurity firms that you may have probably heard of. Those are NetSparker and Acunetics, and we brought together our extensive expertise in web application security. We have a dedicated workforce of over 300 professionals, and we have earned a reputation as a reliable partner in the cybersecurity industry. Altogether, we have secured over 800,000 applications, and we are serving more than 3,600 customers worldwide. Our testing technologies are including dynamic application security testing, also known as DAST, also interactive application security testing, IAST, and software composition analysis, SCA. And all of them are fully automated throughout the SDLC. If you haven't heard much about GraphQL before, you might be wondering what GraphQL actually is. That's not surprising since this is a little bit of an abstract concept. So here are a few key points about GraphQL. So it's a language for querying and manipulating data through APIs. It was also publicly released in 2015 by Facebook. Before they have used it in some internal applications, and I think they also used it for their mobile app in some capacity. The support is very great in every major programming language that you may use to develop a web application. And it uses a standardized language that is transmitted via JSON, POST, and GET requests. So basically the main thing to keep in mind is that you can communicate with a server as a client using GraphQL. It has some very cool advantages over a REST API, for example, and that the format is way more controllable, that you don't waste any requests on data that you don't actually need. And it allows you to get data without having any additional round trips by querying any other endpoints first. It's just one single endpoint that you can use. And so it's not surprising that GraphQL is actually gaining popularity. First of all, usually the frameworks that Facebook publishes are top quality and have a large developer support. One example other than GraphQL is the React.js framework. And specific to GraphQL is the fact that you can fetch all the data you need with a single API call. I just mentioned this before. You also save bandwidth by avoiding redundant requests. Usually in REST APIs, you need to do several requests. For example, you have to fetch a user ID, and once you have that, you may fetch the posts that are associated with a certain user. And so these are already multiple requests that you can avoid with GraphQL. Also, it's easy to integrate microservices into your API with GraphQL. And the most important thing for me, at least, which is a very convenient feature, is the validation and type checking that you just have out of the box with GraphQL, because it comes with the schema you need to define to even start using GraphQL in the first place. We will talk about the schema a little bit later. So now that we have the basics out of the way, we should talk a little bit more about the usage of GraphQL APIs. And there are several key concepts that you may be familiar with in, for example, REST APIs that are slightly different in GraphQL, and they also have a slightly different name. One of these is the GraphQL schema, the thing that would come closest in REST API would be an open API specification or Swagger. And a GraphQL schema is basically some kind of data structure that defines what actually is in the API and how you can use it. There's also the concept of mutations, which you would probably have as like post or put or delete requests in a REST API. We also have introspection. We can talk a little bit later about this because it's also a very important concept that we should maybe look at a little bit more isolated. And there's also a query which would be a simple get requests in a REST API. First, let's start with the schema. The schema describes the layout of a GraphQL application. It comes with all the fancy type checking features that I've talked about before. It basically lets you write in a schema definition language or SDL that is specific to GraphQL. You can define many types of fields for your data, for example, integers, floats, strings, booleans, custom scalars, arrays, objects, and also some GraphQL specific types like ID fields. But you can also specify whether a field should be empty, whether it should contain data in a certain format, and all of these very fine-grained controls over the input data that you want to process. GraphQL will either handle these automatically, or you have to write some short piece of code that specifies how a certain data type should be handled in your API. Another advantage of schemas is that you have your documentation built in, because the schema will also double as documentation. So whatever you are doing with your API, you have to write it into the schema. Otherwise, GraphQL would just not process the input. It will only handle any input from the user according to what is specified in the schema. So if it's not written in there, it just can't happen usually in GraphQL. If we are now comparing GraphQL to a REST API, there are some important differences. The first one is that there's a single endpoint for queries in GraphQL. In most configurations, it would be something like /GraphQL or /API/GraphQL, something like this. And this single endpoint accepts all of the queries and mutations you send to it. The GraphQL requests are handled on there. And if you want to get some very specific data, you just put it in the request and you can retrieve exactly what's in the list without making any further requests. Also, you can get the final data structure just by specifying it in the request. And all of that is a little bit different in a REST API. First of all, you don't have just a single endpoint. You usually have multiple endpoints for different tasks. You also need to run multiple GET queries if the data you want to fetch is a little bit more complex. And another thing is that a REST API usually returns fixed data structures. So the data you want may be in some data structure that also gives you some completely unrelated data that you don't really need for your purpose. One example would be a user object that contains not only the first and last name, but also the email address and so on, which you wouldn't need for a simple display function in a welcome message, for example. So while both give you the data you ask for, it's a little bit more complicated in REST. So after talking a little bit about the advantages of GraphQL, we also have to look at the disadvantages in terms of security. There are a few things to keep in mind when dealing with GraphQL APIs as an attacker and as a developer. And these are very specific to GraphQL. Most often they have something to do with the way that GraphQL passes the data that is sent to it. They also contain some more generic issues with the way that schemas are handled and used. So first of all, attackers may want to figure out what kind of application they are dealing with, what input it accepts, and of course, in general, how it may be vulnerable. And as we established before, there's this real useful thing called a GraphQL schema, and it contains a lot of very useful information for a developer, but unfortunately also for attackers. So usually you would not publish your GraphQL schema for anyone to see. That is mostly used internally when you are defining some new data types, operations, and so on. You will add them to the schema and then add your logic to the actual application. And after that, it's only rarely used. Usually you would maybe take a look at it if you're developing a new feature for your application and maybe on the client side want to fetch some data. You look up how that data may look like, what you should send to the server in order to get the correct data that you need and so on. But there are also some very useful helpers for the development. And usually when you open them, like GraphQL, for example, you will get a little view of what the application is actually doing, what it's capable of. And this works somehow without having the actual schema exposed somewhere on the server side to just look at and download or something like this. And you may have already wondered, where is this data actually coming from? Like, did I expose something on the server and it just grabbed it from some endpoint? Or maybe since these apps are often bundled together with the GraphQL API framework that you're using, it might just like fetch the actual schema from the hard drive and just reads it and uses it within the application that you're using for testing. But no, it's a little bit more complicated than that, because even if you have the GraphQL application on your server and it is on the same server as the GraphQL API, you still have to send an additional background request in order to actually get the schema. And that request is actually a GraphQL request, but a special one. It's an introspection request. And we will talk a little bit more about introspection later in this presentation. And there's also another way to get to the data that you are having in your GraphQL schema if you don't know what endpoints there are. And this is by abusing the GraphQL autocorrect feature that some of the frameworks have. And these are usually used for correcting spelling mistakes, but attackers can also abuse them if they don't know the exact name of a query or field, and they will just brute force the application with a series of very short inputs. But the GraphQL application, if the autocorrect feature is enabled, will try to fix these and tell them, hey, you put in the wrong word, but you meant the other one. And it will therefore give away the name of a field or query or something. Now, what would a secure GraphQL API look like? In fact, the type checking and readable documentation are already there by default, as I've already mentioned. They are kind of forced by the fact that you have to define a GraphQL schema. Another thing that you need to keep in mind, though, because those are not the only requirements for secure API, is that you need some proper authentication and authorization. And you also want to have some rate limiting for certain functionality. To be fair, both of these are not there by default in REST APIs as well. Usually you have to come up with something. Often it's very easy on the framework level to implement these. And GraphQL, it's a little bit more complicated since you have a little bit more freedom to choose data from certain places and put it together. So it's a little bit more complicated. And there are also some GraphQL specific things you need to keep in mind, like the risk of denial of service for recursive queries, for example. And you really should read up a little bit about those. They are unfortunately out of scope for the length of this presentation, but there are great write-ups about them you can find online. And I really recommend you to read them if you want to run a GraphQL API in your environment. With that being said, is GraphQL actually a less secure API than REST? And it's not a less secure choice in my opinion. It has some pretty decent out-of-box security, which is, for example, the type checking that you don't really have in that kind of way in a REST API, except if you build it yourself or if you have some other methods to do this, for example, with JSON schemas and so on. But there's also a lot of things you need to keep in mind. One of them is that GraphQL is often bolted onto existing applications, and this makes things a lot more complex, and you really want to keep this in mind when dealing with these APIs. However, that's not a GraphQL specific problem. The same can happen in REST. But the biggest risk is users trying to implement a GraphQL APIs and not understanding these differences and not really taking care of authorization and authentication correctly like you have to in GraphQL. Now let's talk a little bit more about the discovery aspect of GraphQL APIs. If you're an attacker, you don't really know what's going on if you're just encountering a GraphQL endpoint, and it's really hard to understand what it does without some additional context that you may need for figuring out the functionality and what kind of data it expects. And there is the introspection feature that is really helpful for discovering the schema. You can use that for development and testing, but it's also a very cool thing for an attacker to have because it allows you to basically retrieve the schema. We will talk about this in a second. And as I mentioned before, some GraphQL frameworks also provide autocorrection feature, which is not really that bad, but if introspection is not enabled, it might allow an attacker to brute force the application more easily and get some more information about it without actually having the schema. And yeah, this is really useful for an attacker. But the way more powerful tool than the autocorrect feature is the introspection feature. And the way this works is that the client will send a GraphQL introspection query to the server, which is basically a GraphQL query that allows you to fetch some metadata about the API. In most cases, this will be the exact content of the schema, the fields that are required, what kind of data they should have, or what data type they are, and so on. And it is very useful to get a very good overview over the application without having the actual schema, but it is as close as having the real schema as it gets. And you can also retrieve the schema information just by sending an introspection query. If you want to disable this feature because you say, well, I don't really use it in debugging a lot, or I do my development in a different way and I already have the schema here, so no need for that. In that case, I have bad news for you because most frameworks just outright don't allow you to disable this feature. And the way to go is probably to just install some middleware, which is a little bit hacky, to be honest. The ones that I've seen are not really that great because they are just like using a denial list of words that are coming from the client. And if these words are present in the request, then it will just not send the response, but an error message instead. And this is fine as long there's no bypass, but it's still a bit hacky, and you should basically consider your GraphQL schema to be public. But of course, GraphQL does not only suffer from the very specific GraphQL-related vulnerabilities, like misconfigurations, like or access control issues, or any other type of things that are GraphQL specific, like the denial of service issues that may arise in certain conditions. Instead, they are also vulnerable to some of the classic vulnerabilities that web applications might have. And the Invicti scanner is actually able to scan GraphQL APIs for vulnerabilities like blind command injections, blind SQL injection, command injection in general, also local file inclusions, out-of-band remote code executions, server-side request forgery, remote code execution, and so on. And we don't really make a difference between a GraphQL API vulnerability and another one. We are picking these up automatically when we are scanning and coming across a GraphQL query, but we also support introspection and can automatically detect fields, data types, and so on. After lots of theory, let's actually look at a demo of a GraphQL API being attacked. And in this demo, I am going to show you how easy it is to just set up a scan and target an application that is running a GraphQL API. I will demo the introspection feature. Introspection is enabled. As I said before, this is a typical setup for most GraphQL applications because it's just like not a feature out of the box to disable this. Our scanner will only get a URL, no schema, and we will use introspection to automatically map out the GraphQL schema for testing. So it's a very simple app. It just has a single purpose, and therefore you will only see the important parts. There is also a wide set of vulnerability checks executed against the endpoint, and after that we will get a shell. And this will be a pretty straightforward demo. I also want to mention that Invicti can use known schemas or introspection, but as briefly mentioned before, it's also possible to automatically detect the GraphQL APIs that the application is using. And Invicti does this by simply checking whether there is a GraphQL request being made while scanning the application. And if there is, we will pick up this request. We will see how it is structured, what fields it contains, and then we will inject our payloads into this GraphQL query. And there is nothing more required than that. We will just simply be able to scan it once we pick it up. Now let me share my screen. I hope everyone can see it. So what we're having is a very simple GraphQL API, and I will just quickly demo you how we can actually use introspection to scan this application. First of all, we need to click on the introspection feature that allows us to import a URL using this. And as you see, it's already filled out. I can also quickly show you the introspection query that we're using. You can use a custom one. This is the one that we use. It doesn't really matter as long as it just contains all the important information that you want to have in order to scan the application. Let's just quickly import this. And then we can already start scanning. It's just as simple as that. It will now take a little while to scan, and we can just wait for this. Actually, it will be done real quick. And yeah, as I said, there's not really much that I had to configure here. And as you will see, once this is finished, we will have detected our command injection that we have in this application. Let me just quickly show it to you. There's like the paraname, the parameter type, and you can also see the attack pattern that was used to actually get this, to actually abuse this vulnerability. You can also see some proof that we have extracted, and we are handling this as any other kind of vulnerability, which means we can also use the get shell button to get a shell and interact with the application. In that case, it's just a very, very simple Docker container that we have used just for the purpose of this demo. And yeah, that's basically it. It was not very hard to set up, as you saw. And you can also scan your application normally. If it interacts with the GraphQL API, it will just simply pick up the request, and there's not much else to configure here. All right. So that's it for the demo and the webinar. Thank you so much for joining. It was a pleasure to have you here, and I hope you learned a little bit more about GraphQL and the security challenges that you may face when you are implementing this in your own applications. So we received quite a few questions throughout the webinar, and we will be trying to answer some of them. Unfortunately, we will likely not be able to answer every single one. However, we are probably answering the first three, and after that, if there are any questions left that weren't answered yet, we will come back to you via email and try our best to give you an accurate answer on them. And let me just check the first one that we've got. 1 second. All right. So the question is, we are planning to start adding GraphQL at our company. In the past, we've had a bunch of REST APIs set up behind a gateway, so I'd say we're pretty familiar with the security side of REST. Could you talk a little bit about what's different with setting up and running GraphQL from a security standpoint? And yes, I can give you some more generic hints on what you should look out for. One of these things is the authorization and authentication in GraphQL APIs. In REST, it is very simple because you have your endpoints that are separated, and in GraphQL, you have more or less a single endpoint and some operations that you can carry out within that endpoint. And the data tends to get a little bit pulled from multiple sources or multiple locations in the GraphQL API. And therefore, you need to ensure that on each of the places where the data can be fetched, proper authentication and authorization is enabled, because otherwise you may prevent access from one location and accidentally forget to also enforce the same restrictions in another location. And that might lead to some vulnerabilities and exposure of data that should not be exposed to unauthorized parties. All right, another question. When you did the demo, can you run that kind of test on any GraphQL endpoint? So if we have GraphQL somewhere, we can just point the scanner at it, do the security testing, or does that need more setup and tweaking in practice? So what I showed to you is basically the normal workflow if you're just wanting to scan a GraphQL API. You can simply use the scanner and import the schema if you want, and then run it. You can also scan your main application. So if you have any application, even if it's like a single page application that is written mostly or purely in JavaScript, you can also scan these. We will pick up the requests to the GraphQL API. Once we pick that request up, we will see how the request looks like. If there are any fields that we can inject our payloads in and other considerations. And once we've done that, it's pretty easy to scan and it will happen automatically. You don't have to worry about it really. It's just not very different from a normal type of scan. Okay, and the last question we will handle today is 1 second. All right, I have not seen many vendors offering DAST on GraphQL. Is this because it's not popular enough, or is it too hard to test, or something else? And so there are a few different answers to that. And even though GraphQL was released in 2015, publicly at least, even though that's the case, GraphQL also took a while to really take off. It's now used by more and more applications and websites, and that just wasn't the case not too long ago. And therefore, many vendors just didn't make the effort to implement it yet, I suppose. Another reason for this is that it is kind of hard to implement if you are thinking about it. It's not just normal get and post requests or even like a JSON request that you would usually have. It has these requests have a very strict structure. There is error handling that you need to keep in mind. You have to check which of the types it actually makes sense to scan. There are some types that are not really required to be scanned if they're implemented correctly and stuff like this. And you also have to really rewrite some parts of your code base just to ensure that everything works as good as possible. Like we did the effort, and it was quite complicated at times because you also have to ensure that you integrate a parser for GraphQL into your product. And I think all of these are reasons why some other Dast vendors just don't have this check implemented, and while it will probably take a while until they do, if they tend to implement it at all, because they may not deem it worth the effort. All right, that concludes it. Thank you very much for joining again. I hope you will have a nice day. Thank you.